The Roman warship moved dangerously close to the walls of Syracuse. The sailors expected arrows, stones, or burning oil. Instead, a massive iron claw slowly descended from above. It caught the bow of the ship. The ropes tightened, and the vessel began to rise out of the water. Men were thrown across the deck. Oars snapped. The wooden hull tilted at a terrifying angle. Then the mechanism released its grip. The ship crashed back into the sea and began taking on water. At least, that is how ancient writers described one of the weapons created by Archimedes. But over the centuries, even more incredible stories appeared. Stories of a cannon powered by steam, of mirrors that could set enemy ships on fire using nothing but sunlight, and of a mechanical device in which the sun, the moon, and the planets moved across a miniature sky. Which of these machines did Archimedes actually build? Which stories were exaggerated? And which inventions were created only in the imagination of later generations? To find out, we will reconstruct the story of 7 mysterious machines associated with Archimedes, but we will not simply accept the legends as fact, because almost 2,000 years later, researchers discovered a lost manuscript whose original words had once been deliberately erased. Hidden beneath a layer of medieval prayers was an explanation of how Archimedes found solutions that seemed impossible, and perhaps that lost text contains the secret behind all of his inventions. But first, we must return to the moment when the Roman fleet appeared outside Syracuse. Syracuse was one of the wealthiest and most heavily fortified cities in Sicily. The Romans expected to capture it with warships, siege towers, and overwhelming numbers. What they did not expect was that the city wall itself would become a giant machine. Whenever Roman vessels approached the fortifications, long wooden beams appeared above them. Chains, hooks, or heavy metal gripping devices were lowered from these beams. One of these machines later became known as the Claw of Archimedes. Its exact construction remains unknown. No original plans, mechanical parts, or reliable illustrations have survived, but such a device would not have needed to lift an entire ship completely out of the water. It only needed to catch the bow and tilt the hull. Soldiers would lose their balance. Rowers would no longer be able to control their oars. Weapons and heavy equipment would slide across the deck. Water could pour through the lower side of the vessel. Even if the ship did not sink, it might no longer be able to continue the attack. And at this point, the story begins to sound less like fantasy. Ancient writers really did mention lifting devices used during the defense of Syracuse. Modern reconstructions have also shown that a powerful crane equipped with ropes and counterweights could have tilted a small ancient warship. But this creates an obvious question. How could an elderly mathematician lift ships weighing many tons? The answer was not inside the iron claw itself. It was hidden behind the city wall. The workers were not pulling a single ordinary rope. The ropes passed through a system of pulleys. Every additional pulley reduced the force required to move the load. The object moved more slowly, but the strength of a few men could be transformed into the force of a much larger machine. Archimedes did not invent the lever. He was not the first person to place a rope over a wheel. His achievement was different. He explained mathematically how force changed depending on the length of a lever, the location of its support, and the number of pulleys in a system. Archimedes is often credited with the famous words, "Give me a place to stand, and I will move the earth." Of course, he was not seriously planning to move the planet, but according to an ancient account, he once decided to demonstrate the power of his calculations to the ruler of Syracuse. A heavily loaded ship stood near the shore. Archimedes sat some distance away, took hold of a rope, and began to pull. The enormous ship supposedly moved smoothly toward him. After more than 2,000 years of retelling, the story may have become far more dramatic than the original event, but the basic effect is completely real. A properly arranged system of pulleys can allow one person to move a load that would be impossible to shift directly. The Claw of Archimedes no longer sounds like magic, but before using such a system against a warship, it would need to be tested on something enormous, and Archimedes may have been given exactly that opportunity. The ship was called the Syracusia, According to ancient descriptions, it was one of the largest vessels of its time. It supposedly contained vast cargo spaces, private rooms, defensive towers, and even luxurious halls. Some writers described it almost as a floating palace. Many of these details were probably exaggerated, but the ship itself most likely existed. Archimedes was traditionally credited with helping to design the vessel and move it into the water. Here, several of his technologies may have come together as one system. Levers and pulleys would have been needed to move the enormous wooden hull. Careful calculations would have been required to prevent the vessel from tipping over, and another machine would have been needed to remove water from the lower decks. Even the finest wooden ships of the ancient world constantly took on water. The joints between the planks leaked, waves washed over the sides. Men working below deck had to remove the water by hand. But on the Syracusia, this exhausting task may have been performed by a machine. At first glance, the device looked remarkably simple. Inside an inclined tube was a large spiral. A person turned a handle. The spiral rotated, trapped a small amount of water, and carried it upward. The next turn raised the water a little higher, then another turn and another, until the water finally poured out from the upper end of the tube. This was the Archimedes Screw. The same principle could be used for more than removing water from ships. It could irrigate fields, drain low ground, and lift water from canals. The most remarkable fact is that the principle never disappeared. Archimedes screws are still used today. They move water, sewage, grain, and other loose materials. In some modern systems, the process is reversed. Flowing water turns the screw and helps generate electrical power. However, there is one important complication. Similar water lifting devices may have existed before the time of Archimedes. He may not have invented the entire mechanism from nothing. Perhaps he encountered an earlier design, calculated its ideal proportions, improved it, and made it far more effective. And this reveals something important about Archimedes. He did not necessarily need to invent every individual component. His gift was seeing the hidden law inside an ordinary machine and transforming it into a reliable system. Meanwhile, the Romans had learned that moving too close to the walls of Syracuse was dangerous. Their ships began to remain farther from the city. The iron claw could no longer reach them, and this is where later legends gave Archimedes a weapon capable of striking an enemy from a distance. Imagine a long metal tube. The rear section is heated over a fire. A heavy projectile is placed inside. Then a small amount of water is injected into the heated chamber. The water instantly turns into steam. Its volume expands. The pressure launches the projectile from the tube. This is how the steam cannon later associated with Archimedes may have worked. From the perspective of physics, the principle is possible, but building such a cannon would be only half of the challenge. The metal chamber would need to survive a sudden rise in pressure. After every shot, the tube would need to be heated again. The amount of water would have to be calculated very carefully. Too little water and the pressure would be too weak. Too much water and the chamber might explode, killing the people standing around it. This is where the historical evidence becomes much weaker. There is no reliable account showing that Archimedes used a steam cannon during the siege of Syracuse. Detailed stories about the weapon appeared much later. Perhaps Archimedes really did experiment with steam, but it is also possible that later generations simply credited him with a technology they found fascinating. And yet the steam cannon is not the most famous legend connected to his name. The next machine required no fuel, no steam, and no projectile. Its only ammunition was sunlight. Dozens of soldiers stand on the walls of Syracuse. Each man holds a polished bronze shield or reflective surface. At a signal, they direct the sunlight toward a single Roman ship. The reflected light grows brighter. Smoke appears on the sail. The fabric darkens, then flames suddenly rise. This is the legendary death ray of Archimedes. The story is so extraordinary that researchers have attempted to recreate it many times. They used dozens and sometimes hundreds of modern mirrors. In certain experiments, they were able to heat a wooden target. Sometimes the wood began to smoke, and under especially favorable conditions, it could even be set on fire. But the experiments almost always required nearly perfect conditions: bright sunlight, a short distance, a motionless target, and many reflected beams held on exactly the same point for a long time. A real naval battle would have been completely different. The ship would be moving with the waves. The sails would be shifting in the wind. Smoke might block the sunlight. The people standing on the wall could not keep dozens of reflections perfectly aligned, and polished bronze would have reflected less light than a modern glass mirror. There is an even more serious problem. Writers who lived relatively close to the time of the siege described many of Archimedes' mechanical defenses. They mentioned catapults, hooks, and lifting machines, but they did not describe an entire Roman fleet being burned by reflected sunlight. The detailed story appeared later. Does this mean reflective shields were never used? Not necessarily. Bright sunlight reflected from metal could have blinded sailors. It could have distracted archers and observers. Perhaps reflected light was used as a form of confusion or intimidation, and over time, a small real event may have grown into a legend about a weapon that could burn entire ships. But if the famous death ray was probably a myth, why were people so willing to believe it? The answer may have appeared after the fall of Syracuse. The Romans eventually entered the city. Archimedes was killed, but one of his machines survived as creator. The Roman writer Cicero later described an extraordinary device that had been taken from Syracuse. It was a mechanical model of the heavens. When someone set it in motion, small representations of the sun, the moon, and the known planets moved as they did across the real sky. Today, a model of the solar system may not seem especially mysterious, but imagine such a machine more than 2,000 years ago. Inside, there must have been axles, wheels, or gears. Each celestial body needed to move at a different speed. A single movement of the mechanism produced several connected motions at once. A person could place the universe in motion with one hand. The planetary device created by Archimedes has not survived. We do not know exactly what it looked like or how accurately it represented the heavens, but unlike the steam cannon and the burning mirrors, accounts of such a machine appear in ancient sources. And centuries later, archaeologists discovered the Antikythera mechanism. It was an extremely complex, ancient Greek device containing many bronze gears. It could calculate celestial cycles and predict certain astronomical events. The Antikythera mechanism was not the machine of Archimedes. It was created later, but its existence proves something extremely important. Ancient Greek engineers really could build complicated mechanisms in which dozens of moving parts reproduce the cycles of the heavens. The story of Archimedes' planetarium no longer seems impossible, and now we reach the most important question. How could one person understand water, ships, levers, siege machines, geometry, and the movement of the planets? The answer was lost. The pages containing it were taken apart. The original writing was scraped away, and prayers were written over the top. During the Middle Ages, parchment was expensive. Old manuscripts were sometimes erased and reused. This happened to several works by Archimedes. His ancient pages were transformed into a religious prayer book. It seemed that the original words had disappeared forever, but the ink had not been completely removed. In the early 20th century, a researcher noticed faint ancient Greek writing beneath the prayers. Later, modern imaging techniques helped scholars read words that were nearly invisible to the human eye. Among the recovered works was a text known as the Method. In this work, Archimedes revealed his unusual approach to solving problems. When faced with a difficult question in geometry, he did not always begin with a formal proof. First, he imagined geometric shapes as physical objects. He imagined that they had weight. He placed them on an imaginary lever. He balanced them, and he watched for the answer suggested by the mechanics. Only after that did he create a strict mathematical proof. Now, the 7 mysterious machines begin to form a single picture. Archimedes did not separate mathematics from the physical world. He looked at a ship and saw a system of forces. He looked at water and saw its movement inside a spiral. He looked at the sky and imagined a hidden mechanism. This is why even the most unbelievable legends became attached to his name. People believed that if anyone could build an impossible machine, it was Archimedes. So, which of the 7 inventions really existed? Archimedes genuinely studied levers and mechanical balance. Complex pulley systems were available to the engineers of his time. The Archimedes Screw is completely real, although it remains uncertain whether he was its original inventor. The enormous ship Syracusia probably existed, but later writers may have greatly exaggerated its size and luxury. Lifting machines used during the defense of Syracuse were mentioned by ancient authors. The Claw of Archimedes may therefore have been based on a real device, although its exact design is unknown. The mechanical planetarium also has a serious historical foundation, but the original machine was lost. The steam cannon remains a controversial later claim, and the famous burning mirrors almost certainly did not destroy moving ships in the dramatic way shown in films. This leaves us with a strange conclusion. The most famous machine associated with Archimedes was probably a legend, and his most extraordinary achievement was not a weapon at all. It was a way of seeing invisible forces, the power of a lever hidden inside an ordinary wooden beam, the path of water hidden inside a spiral, the movement of the heavens hidden inside a system of wheels. The Romans managed to capture Syracuse. They may have destroyed some machines and carried others away. Centuries later, people even erased the words of Archimedes from the parchment, but they could not erase his most important idea. An impossible technology begins at the moment when one person sees a law that remains invisible to everyone else. Subscribe if you enjoy historical mysteries in which the truth can be even more surprising than the legend. Which machine of Archimedes do you believe was real? The iron claw, the steam cannon, or the burning mirrors?